Yes, very good morning, students. I welcome you again. We are meeting this time. This is actually vector calculus, lecture number 16 that we want to share with you. It is on application on surface integrals. Well, I want to solve here some typical problems on the surface integral, how we evaluate the questions on surface integral. I have already told you the geometrical significance in lecture number 14 and 15. When you want to go through this lecture number 16, it is very important for you to revise, to just go through lecture number 14 and 15. In 14 we have introduced the surface integral, we have defined the surface integral, and in 15 lecture number 15 we have derived the formula how we evaluate ds in different formulas. It is very important there. Well, I have some typical problems that I want to share with you. This is the applications. Now with this we will do this one or two, more than two lectures on this application part. It is find the surface integral for the vector point function f is equal to minus 4yk over the rectangle which is bounded by the lines x is equal to plus minus a, y is equal to 0, y is equal to b. And second is evaluate the surface integral f, where f is given by this. S is the part of the surface x square plus y square plus z square equal to 1, which lies in the first octant. We have some more applications that I will just write later, because this part may not be visible for you. Let me have the solutions of these problems first. This is the solution here. We want to solve these. Well, first problem says the surface integral f is given by, we have f is given by, to find surface integral of the vector point function given by what? It is f equal to minus 4 y k, unit vector k, over the rectangle. Rectangle is bounded by the lines x is equal to plus minus a, y is equal to 0, y is equal to b. You observe this is obviously lying in xy plane. It is in xy plane. If you have this part here, this is your x is equal to minus a, take this as x is equal to a, this is your y equal to 0 line. Let us assume that this is y equal to b. Then you have the coordinates here. This will be, name this as a, this is a coordinate is minus a 0. If this is b, this is b, is a0 on x-axis, and this will be x is a, y is b, ab, and this part is, let it be abc, this is d, this is minus ab. Okay, we want to find out this is c here, a b c d. This is your region R. We want to find out our surface integral over this region, and it is obvious that this region lies where? It lies in the xy plane, because you directly observe that here you have involvement of this x and y. We write here the required surface integral over f is equal to minus 4y k is given by surface integral over the surface S, f dot n unit vector unit normal vector along the, it is a normal unit vector outward the surface ds. Okay, and this you can write, it is now double integral, or we will write this first where our surface is given by this. We have to find out this. Okay, we write here the required surface bounded by, which is bounded by x is equal to plus minus a, y equal to 0, y equal to b, lies purely in xy plane. It lies in xy plane. It's in xy plane. So when it lies in the xy plane, if it is parallel or lies in a plane, we project it in that very plane. Lecture number 15. So we project the surface which is rectangle in xy plane. So what is the surface integral then? Therefore surface integral will be given by our surface integral over S. It is the surface integral over S f dot unit vector, unit normal vector outward the surface is given by double integral over the region R. It is f dot n. What is ds here? It is ds by unit vector n dot k, because when it lies in the xy plane, we have there the normal perpendicular to the plane, it is k. I will not throw light on this again and again. We have fully explained this in lecture number 15. Just you go there and you will come to know why do we write this n unit vector dot k. If it lies in the yz plane, then it is accordingly this k will get changed, because you have to see what is the perpendicular there. Well, we will find out this here. Name it first. Sinus rectangle lies in xy plane, rectangle lies in xy plane, what does this mean? This means your unit vector, unit normal vector, normal unit vector outward the surface is directly k. We have explained this also in your lecture this 15. It is here ds is getting replaced by, because it is in the xy plane, we are fully writing this now ds as dx dy. Sorry, it is dx dy because it lies in the xy plane. You are certain lying in the xy plane, that is why we write here this. Now what about this? Implies that when you find out magnitude of unit vector n dot k, this will be k dot k, it is obviously 1. Therefore we have, this implies that surface integral, required surface integral that we are going to find out is double integral over R. It is f dot n dx dy by 1. Okay. Well, after this you have to find here what is f dot n, unit vector n. Your f is given by, it is f minus 4 y k minus 4 y k it is dot, what is your n? It is k. So this is simply k dot k is 1, it is equal to minus 4y. Therefore I replace this now. This is x going from, your x is from minus a to a, and y goes from 0 to b. Here x is minus a to a, y goes from 0 to b. This is y going from 0 to b. This is your f dot n, it is minus 4y. This you will write only dx dy. Now you have to simplify this, you will get the result. Well, this is your surface integral over the given surface f dot n ds is given by double integral of x going from minus a to a, integral y from 0 to b. You can take minus 4 out, it is constant. I will write here y dy. Okay, it is y dy. I will first integrate y with respect to this. I will integrate, keep dx out, because this is the limit for y. I took here dy first, and I am integrated this with respect to y. You see the value limit for y is from 0 to b. This is your minus 4 here, integral x turning from minus 3 to a. This is your y square by 2 from y 0 to b, then dx. This is your minus 4, integral for x is limit minus a to a, it is by 2 out. Give the value first b, it is b square minus 0. So you have out, it is minus 2 b square, integral of x running from minus a to a, 1 dx. Dx is here continuing, it is dx. Okay, when you integrate this with respect to x, it is x. This will be minus 2b square. This is x, integral of this one from minus a to a. This gives you minus 2b square. This is a plus a, because upper limit minus the lower limit, that becomes a plus a. This is your minus 4ab square. This is the required surface integral S of the function f dot ds. This is your surface integral of this vector point function over the rectangle which is bounded by these lines. X is equal to minus a, x is equal to a, y is equal to 0, y is equal to b. This is how you find out when you are in a position that the your given surface is directly lying in some part, some plane, xy plane, yz plane, or z-axis. Even if it is parallel, then we will follow in the same way when it is parallel. Okay, let us have solution to second problem, problem number 2. Well, you look to this problem. It is solution of problem number 2. What does this say? You have to evaluate, find the surface integral, find surface integral over the given surface S of the vector point function f dot ds, where your vector point function is given by, it is yzi plus zxj plus xy unit vector k, and S is the part of the surface, S being part of what? X square plus y square plus z square equal to 1. You know what is this? It is a sphere. It is sphere having radius equal to unity. It is radius is unity. Well, when you draw this surface this way, it is a sphere. This is your sphere, assuming this is your origin, because it is center is origin. It is center is origin. Radius is 1. So this point you can say, let it be A. It is a 1 0 0. Okay. Now I will deliberately take this as x axis, this as y axis. Let me take this as z axis. It is at your this x to choose x y z. There is no hard and fast rule to fix it. There is no fixed this name for. You can even take this x, this y, this z. Sometimes you take this x, this y, this z. Doesn't matter, because I took it because I want to project. Now what is the position of this what is called the sphere? It does not lie wholly in one plane, neither in xy plane, nor in yz plane, nor in zx plane, nor is it parallel. It is not parallel to a particular plane. It is scattering. So we have to see, we can project it in this way, in yz plane, in xz plane. We can project it here, we can project it here. Okay. So let me project it in xy plane. If we project it here, projecting in xy plane, so this is the part of the surface which you are projecting in this plane. You cannot project full. You see, I will explain just a minute. You have this sphere. Consider this as sphere. This sphere is not going to this fully in xy plane. If it is parallel or lies in the xy plane, then you will project full in this part. If it is parallel to this plane or lies in this plane, you will project in the same. Or if it is like this, but it is in this way, it is in this way, it is in this way. Okay. Neither lying fully in any plane nor parallel fully in particular. It is like this plane. Although it is not 2D, it is a 3D. I am just explaining this. So you have to project that part which is visible from a certain plane. Okay. So this part gets projected. You will project this in xy plane. Projecting in xy plane. So we are given, this is our surface integral that we have to find. We project it in the xy plane. When you project it in xy plane, it will be like this. You see how we proceed. We project the given surface, which is our sphere, in xy plane. When I have given the name to this as x-axis, this y-axis, this is z-axis. Okay, xy plane. Now the question is, I have already told you in lecture number 15, when a certain surface lies in a particular plane or it is parallel to a particular plane, then we take n cap, that is the normal unit vector, to the outward to the surface, n cap. This we take that. Suppose if it would like here, I would take this unit vector along this was unit vector along this as k. This is here unit vector I. Along y-axis unit vector is j. But in this case it is not lying in any plane. We are projecting this plane. We projected this surface in the xy plane. And how we find out n cap here? Yes, when we project in the xy plane, then what is our surface integral? Then required surface integral is Remember this, go to this lecture number 15. The required this surface integral is given by, it is integral of S f dot ds will be given by integral of S f dot n, unit vector n, outward to the normal, outward normal to the surface. This is dx dy by, this is your n dot k. Okay. Now just look how we find out this f dot n and n dot k. Let me name this here, say equation number 1. I will again go there. I will first find out n. In this case, the normal unit vector outward to the surface is given by gradient formula. Please go to lecture 15 where I explained this fully. When we have such case, it is the plane is neither lying wholly nor parallel to wholly, but it is just part of the surface lies in one plane. Then we project that part in the xy plane or yz plane. But in that case, n is given by gradient. What is given by, what is this gradient? Oh, I have named this, so don't worry, I will write this equation number 1 again, no problem. Where your unit normal vector is given by gradient of phi, that is del phi. Now what is your phi? It is given by the surface. It is x square plus y square plus z square minus 1 is equal to 0. So that n cap is given by gradient of phi. It is I times del phi by del x, j times dou phi by dou y, plus k times dou phi by dou z. Find here dou phi by dou x will be 2x, dou phi by dou y is 2y, dou phi by dou z is 2z. So this is your n cap is given by, it is not equal to this, I just write it is given by the gradient. I first find out gradient here, where gradient of phi is this, because the formula for finding n cap is this, it is gradient of phi by magnitude of the gradient of phi. Then it is the unit vector along the gradient, because in this case we find out unit vector along the gradient of phi, that is given by this. I am just to find out only gradient of phi. This is your 2x, it is 2x I plus 2y j plus 2z k. Now what is your unit normal vector? It is n cap is equal to grade of phi by magnitude of the grade of phi, that is equal to 2xi plus 2yj plus 2zk, and take the magnitude of this, magnitude of, I am again writing here n, I should not write this n yet, it is your gradient of phi. This is your gradient of phi, I am sorry. It is gradient of phi is this one. Now I am find out unit vector, the formula is this. This is gradient of phi by magnitude of this, gradient is this. What is it is magnitude? It is under root of coefficient of I square, this is 2x square 2x square plus 2y square, then plus 2z square, and this comes out to be unit vector n cap. It is 2xi plus 2yj plus 2zk by, it is under root of 4 is 2 is out, it is x square plus y square plus z square. What is my x square plus y square plus z square here? 1. I can use this one. This is equal to 2 out, it is xi plus yj plus zk by 2 into root 1. This is only xi plus yj plus zk. Therefore, you have got the unit normal vector n cap. It is simply given by xi plus yj plus zk. Now we find out n dot k. What is this? Your n is xi plus yj plus zk dot k. It is dot k. So this is your only z. So n dot k is z. Next, you find out this what is your f dot. You just underline this we require f dot n cap, that we require in the integral, double integral. This is your, what is your f? Write it again. It is your yz I plus zxj plus xyk. It is dot with this xi plus yj plus zk. Do you follow? Now take the dot product. This is your xyz plus zxy plus xyz. So your f dot n is, it is 3 times xyz. So you have got this thing also. What is f dot n? This is 3 times xyz. Now you can use the integral. Then you have to find out the limit here. Limit is very important. Now by equation number first, we have surface integral s dot ds. This was given by double integral over the region R. Region R, first we write region R. It is f dot n dx dy magnitude of n dot k. This you have found. Double integral over the region R. What is your f dot n? You have found it. It is 3xyz. This is your dx dy. What is your n? It was z. That means you are getting this as double integral over the region R. Z goes. It is 3xy dx dy. This is your equation number second. Name the second equation. Now the main thing is to find out the you have projected it in this region. We have to find out it is limits. Limit for x is known. X is for 0 to 1. Now what about for y? You see how we go. You have done the double integral in previous semesters. When you have to find out the double integral, you sometimes you don't have the this second, say, y coordinate or z limit, y limit or z limit. What you do is you draw a vertical or horizontal strip. If you remember, vertical or I don't need here to draw the vertical horizontal strip, because I know the value for x. I need y. I will draw the vertical strip. You see how. Well, this is now my x-axis, y-axis, z-axis. I have projected this part of the sphere. This is a coordinates. This is your region R. Now here in this case you have only x square plus y square equal to 1, this part, because here z is 0. In this range you have z 0. When you put z is equal to 0 in this, x square plus y square plus z square is equal to 1, that will give you x square plus y square equal to 1 when you put z 0. Now what you do is you draw, this is known as vertical strip. For x I have the limit for x running from 0 to x running from 1. For x I have the limit. Now how we go for this? I draw here a vertical strip to find out this is your vertical strip from x-axis. Naturally the equation of x-axis is y equal to 0. Now you have to find out here what is the value for y. How you solve it? Value for y, I will give it here. You have in this xy plane, x square plus y square is 1. You have x square plus y square equal to 1. That gives you y square is 1 minus x square. That implies that your y is plus minus under root of 1 minus x square, but your sphere is given to lie in the first octant. When it is in the first octant, you have to choose positive. You have to choose the positive value of y. You will take y is equal to under root of 1 minus x square, being lying in the first octant. So your y is here under root of 1 minus x square. Therefore you have got the value for y. You know the equation of this curve from which you have drawn the vertical strip. You know it is equation x square plus y square. From this we have got the value of y in terms of x, y running from 0 to under root of 1 minus x square. This is the method how you find out the limits. Well, now you are in a position to evaluate this. Write this 3 out. I don't need it. This is from x running from 0 to 1. This is for the x limit, and y you have found. Y is from running from 0 to under root of 1 minus x square. Okay, then this is your xy dx dy. Now I have to evaluate this one. This limit we have found, you don't need it. I will rub it. Let us evaluate this. You can write it now. This is 3 integral x going from 0 to 1. X I will write here. Then integral y going from 0 to under root of 1 minus x square. I will write here y dy, because we have to give dy with that integral which has the limit y running from and y values to that integral. You know the double integral. Dx is out. This x I kept out. This is for this dx, and this is y dy. I have distributed in multiplication the value of y term, y function with integral of where we have the limit y dy. This is double integral. What you do, how you do it? Well, this will be your 3 integral x running from 0 to 1. What is the integral of y with respect to y? It is y square by 2. This is y square by 2, and you have to give the limit for this from y running from 0 to under root of 1 minus x square. This is your dx here. Well, outside you will get this is your 3 by 2 integral. Yes, we have perhaps forgotten here to write x. Yes, here it is x. It is x here. 3 by 2, 0 to 1. This integral goes. This will be now x minus x cube. X minus x cube dx. Okay. Now we have to integrate it with the with respect to x. This is your 3 by 2 integral of 0 to 1 x dx minus integral of 0 to 1 x cube dx. This comes out to be 3 by 2. This is x square by 2 from 0 to 1, then minus x4 by 4. It is 0 to 1. Okay. Now we will be giving the limit here. It is 3 by 2. When you give the limit 1, it is 1 by 2 minus 0 by 2, because upper limit is 1, lower limit is 0. It is simply 1 by 2 minus, this will be 1 by 4 minus 0 by 4. This is 1 by 4, and this on simplification gives you 3 by 2. It is 4 LCM. This is 2 minus 1. It will be 1. So this is 3 by 8. Well, the value of this integral is surface integral is 3 by 8. If it is not visible here, I can write it here also. It is 3 by 8. Okay. Well, we will be coming soon with some more this examples, this applications on this surface integral, and we will solve some more, and then we will go to line integral. Thank you very much. We will be meeting soon. Thank you.